one really important, here I got my elements book here, check it out, is aluminum. There's a big block of it. Story time, yay! Alright, it says aluminum is a ideal metal, though it could be improved a few ways. It could be as cheap and easy to weld as iron, or it could take to casting as well as zinc or tin. But strong enough and light enough to be formed in most airplanes, except for the most exotic ones, obviously. And the pure metal was, when it was first produced, even Napoleon III served his most important guests on aluminum plates, because it was considered to be, you know, harder to produce than gold and silver. So yeah, things have changed a little bit. And one of aluminum's, it says here, signature advantages, I guess. I don't know, I don't really think it's a signature advantage. I just think it's what happens. But aluminum, when it's exposed to air, it oxidizes and forms a protective layer of what's called corundum. And that's Al2O3, aluminum oxide. And those that know what corundum is, it's basically the generic form of ruby and diamond. So literally, if you have a lot of aluminum lying around and it's rusting, just scrape off that white powder, that's corundum. That's the same thing rubies and diamonds are made out of. So a little idea there for you. I'm not saying you can make rubies and diamonds out of rusting aluminum, but here I have a heatsink. My boss threw away some of his old computers, and I went ahead and scavenged this just for, you know, keepsake purposes. Just, you can use this for experiments. I guess you can probably take like a Peltier cooler and put it on there, but the processor, the main CPU processor, sat right here with, of course, some like heatsink stuff, some gray I can't remember what it's called, not epoxy, but there's a word for it. But it sat right here, and you know, obviously the fan would be blowing through this direction, pulling the heat away from the processor. And aluminum has a very high thermal conductivity, and it is very highly electrically conductive, which is really cool because gold is the same way, silver is the same way, copper is the same way. They all conduct electricity very well, and they all conduct heat very well. But the upside for aluminum is that it's a whole hell of a lot cheaper to produce than is gold and silver. And for the most part, even copper. Copper is much more expensive than gold, or copper is more expensive than aluminum. So there you go. I even went online and I learned how to make a little air blast furnace. So I took aluminum cans and I made these little things. But yeah, I used a steel pan. This is the bottom right here. And when I poured it in, obviously, if you can see the little slag, there's a little bit of slag left over on the top of these things. This one's a little bit better. But if you can see the slag on there, because when I poured it in, the slag was still, some slag was still sitting on top, and this end ended up real smooth and shiny and pretty. So it takes about 25 cans per to make one of these, you know, given you have loss to slag. But those are pretty cool. But what I really wanted to get talking to was the fact that astronomers and astrophysicists, since they consider planet formation to be something other than star evolution, they're lost in the sauce basically. Is the reason why I'm saying that is because they don't think about aluminum in the correct light. They look at stars and the evolution of them as being a hydrogen and helium only kind of thing. And then all the others are just these metals that just have very little practical significance to star evolution. Little do they know, as the star evolves, cools and dies, it becomes what's called the planet. So literally we can reverse engineer the Earth to see where all of it was in earlier stages of evolution, when the star was much bigger and bigger and bigger and bigger, to the point to where it was fully ionized, and you know, the gravitational collapse of it would cause further ionization, and there was like a feedback loop. I went over that in a previous video. But the fact is that aluminum is the most abundant metal in the Earth's crust. It's pretty silvery metal which can be used to make almost anything, literally. And it's not in its free form. And I think that's one of the important ideas I wanted to share, is that why is it that aluminum is always combined with other elements making molecules? Well, I think it's because it's highly reactive when it's really small. There are certain rules against it being sold as smaller and smaller and smaller pieces. There is a particle limit, in other words. If you sell aluminum really, really finely powdered, it's very, very reactive, and it's even used in fireworks and explosives and even rocket fuel. But if it's just not really powdered that much, if the particle size is a bit bigger, and it doesn't really react that much, and I guess it has something to do with the amount of surface area on the particle in relation to the environment. But really though, as the star evolves, why is it that aluminum, and also silicon, but more on that later, tend to be in very high amounts in the crust? What made it to where they were the most abundant inside the Earth's crust? They're two of the most abundant elements. Now you say, oh well, it must be because they're lighter and they were staying on the surface. Well, that wouldn't really make too much sense, because since aluminum is combined with oxygen, Al2O3, it makes corundum, and corundum has a very high specific density. In other words, it wasn't elemental aluminum, it combined with oxygen and then it sunk to the center. So literally the chemical reactions for aluminum to oxygen happened in a very, very high atmosphere of Earth when it was a large gas giant. And then those chemical reactions took place, and then it sunk down into pre-existing rocks that were forming already. I remember when I went to the Smithsonian, I saw a big chunk of rock with large ruby crystals in it. Or corundum, I guess you wouldn't say ruby because they're red, but they were just like scattered all over inside of that rock. So literally it means that those crystals were formed in a very high temperature, high pressure environment where they could move around freely. And then they dropped, and then the rocks formed around them. So the crystal formation happened before the surrounding rocks were forming them. And that's very, very, very weird to me, because I have a lot more explaining to do. But all in all, the aluminum is combining with all these elements inside the atmosphere, releasing heat as it combines. So there's something to do with the way heat is transferred and the way the elements combine in certain ratios in certain areas of the Earth's crust as it was forming. So, you know, keep that in mind if you're trying to work out how all these reactions took place inside the interiors. But yeah, I think that really sums it up. But later I'll go over copper, and also bring in some copper if I can get my hands on some at work. It's a really cool element. Alright, today is July 16th, 2015. Later.